Here's Precalculus problem 10-100. It says a large picture weighing 40 pounds is being suspended as shown in the diagram at right. How much tension is on one side of the cable? Okay, so I wasn't quite sure how to do this one, so I looked in the answer key and I saw this diagram. So from what I make of this, I know that vectors they can kind of go in, they have magnitude and direction, but you could pick them up and move them around. So when I look at their diagram, I want it to make sense with the picture that's hanging. This is the picture with the guy's face on it that's hanging. And I can get how there would be a vector that's going down 40, so these are the x components and the y components, right? So the x component, that makes sense because the nail's right here. It makes sense that there would be a downward component of -40 because of the weight. These ones, I didn't like how they were going out this way, but then when I drew my own picture and thought about the vectors, I thought this vector right here, its component, like if I put this vector in component form, I could say this side is 2.5. I could say it went right by 2.5 and up by 1. And that's kind of what they have. This is their diagram. So I guess I can make their diagram make sense because this, I mean, doesn't it make sense to us that this side is holding 20 pounds and this side's holding? Oh, and I thought I needed to know that length, but I don't think I ended up using that. Right, it feels like each cable, it just makes common sense that each cable's going to be holding half of the 40-pound load. This cable has if this cable were a vector, its component going right would be 2.5, and its component going up would be 1. And so that kind of matches this one. I'm just going by their diagram. But they're multiplying it by force, like 2.5 times the force, because it's that length, plus 1 times the force. And it even says here, I'll let you read this for yourself. It says, let F be the force distributed from the weight of the picture. Now, since the picture's not moving, the resultant vector is going to be 0. And I hope that makes sense. So they're adding these two vectors, which now kind of makes sense because you can think of this vector as that one and this vector as that one. And then when you add all the vectors up, the thing's not moving, then they got 2F, because if you look at can you guys see that? If you look at the side-to-side movement, the X components, they're going to kind of zero out, right? So you have -2.5 and +2.5 and 0. But the up and down, like the Y component, the second component here, that has to do with the up and down movement, we've got 1 plus another 1 minus 40 equals 0. So they said, well, 1 plus 1 is 2. 2F minus 40 equals 0. So the force is 20, but we knew that. I think we knew that just by looking at the picture. It would be 20 and 20. So then what do you do with that information? So they said thus the vector for one cable is plus or minus 50, 20. So how is that? That's because we said our vector was 2.5 times force, 1 times force. So if the force is 20, is 2.5 times 20, which is 50, and then 1 times 20 is 20. And so then that gives us a vector and component form, and then we can go ahead and get the magnitude. Like, you know how you can get the magnitude of a vector? You just, the magnitude is this piece right here, right? So if it's right by 50 and up by 20, you can go 50 squared plus 20 squared equals this hypotenuse here. So that ends up being 2900 equals c squared, and the c is the square root of 2900. So the length of this vector is 53.851 pounds. So that's what I got.